Hello, everybody. We're going to do inequalities in one triangle, lesson 4, page 123. And so we'll get started here. As you can see, we're going to learn what the relationships are between the sides and angles of a triangle. And you're going to be able to use theorems to compare the sides and the angles of a triangle. So the first thing you would do is you take a look at these sides, and it says, you're supposed to drag and rotate. If you are online, I did make it here where I can kind of move these. And so what you're supposed to do is drag and see which one of these would make triangles, okay? Like which ones. And if you sit there and you maneuver some of them, it won't come out perfect. But let's say I picked 10, 7, and 6. Well, that looks like it would make a triangle. 4, 3, and 2 would. But what happens if we did 10, 4, and 3? Would these actually connect to make a triangle? And as you can see, they don't. So what you're supposed to do is kind of take a look and be like, okay, well, what can you figure from that? 6, 7, and 10 did, but 10, 4, and 3 didn't. What do you think? Would 2, 4, and 6? And because this one kind of gets some students confused, but if you take 10 and you take 6, 4, and 2, as you can see, well, 2 and 4 are going to make 6. So that wouldn't make a triangle. They'd lay right on top of each other. And so at this time, you should kind of just say, well, how do I know something makes a triangle? And that's what we're going to kind of learn here. So on example 1, it says draw a right triangle and a non-right triangle. And it asks about the angles. And so within the online textbook, you can sit there and manipulate these triangles and things, make a right triangle there. And I want you to take a look at the angles, all right? Look at the side lengths. So we have our 90 degree right here, okay? And you got your 67, and you got your 23. Well, let's put them in order of the largest to the smallest. Well, angle A would be the largest at 90. Okay, angle C would be next at 67, and angle B would be your smallest at 23. Then take a look at your sides. A to C is 5, that's my smallest. A to B would be 12, and C to B is 13. Okay, so kind of take a look at that. Well, what do you notice about C to B, 13 here? Okay, is what letter is not with CB? Well, A isn't, right? It's across from it. Now notice, look, 13 is the biggest, 90 is the biggest. Well, hey, what do you know? They're across from each other. They're opposite from each other. All right, let's take a look at the smallest one. 23 is the smallest. And B, AC, right, it has no B in there. So therefore, it's across from there. So what can we learn from this? What is the thing that you can sit there and actually say is that the largest side, the longest side, is across from the largest angle. The smallest side is across from the smallest angle. Okay? So something to kind of just keep in mind there. And here you go. If B is larger than A, that's what an inequality is, greater than, less than, that's what these are. Well, then angle B is bigger than angle A, okay? So it's kind of a funny little problem here. They built this sign for a float, and it says they have a triangular piece of float, on the float. A brace is placed, a brace, at the largest angle. Well, which one would be the largest angle? Well, I got 10, I got 13, and I got 12. And you might as well do green because that's what they did. So green is 13. Oh, where would I put the brace if it's at the largest angle? It'd be on angle C. And then it says it has a wire placed at the smallest angle. Let's take a look and see which one's the smallest angle. Well, I got 12 and 10. Well, 10 is smaller than 12, right? and B. So they would put a wire at B, the smallest angle, right? And they put there. So kind of goes back and forth there. And as you can see, since 12 is bigger than 10, angle A is bigger than B. Since 13 is bigger than 12, the angle C is bigger than A. Kind of goes through that. All right. So here's your first try. Lucas sketched a diagram. Here's his diagram. Which angle would be your largest? So I'll give you a second there. Which one would be the largest? Look at your three sides. I got 8, I got 10, and I got 14. Identify your largest side. Well, 14 is. What side is it across from? E. Therefore, E is the largest. Which one is your smallest? Well, since 8 is your smallest, it's across from D. D would be your smallest angle. All right. And so the converse of this is basically if you know the angle sizes, then the sides across from there go in the same order. It says indirect proof. I skipped this, right? And this is basically proving it. But okay. Now, a lot of students get to a problem like this and they're like, oh no, I can't figure this out. I don't know the third angle. Well, yeah, you do. You know that the third angle of a triangle, or all three angles, add up to 180. So you would take 62 and 50 and you'd add them up together, which gives you 112. You know all three add up to 180, so you take 180 minus 112 and you get 68. So I'm going to throw in a 68 degree here. It says which side would be the longest? Well, let's take a look. 68, 50, and 62. Well, 68's the biggest. What side is across from it? LM. Therefore, LM is your biggest. So go ahead and do your try it. Pause the video at this time if you need to before I give you the answers. All right? They want to know which side is the longest and which side is the shortest. So pause the video. All right, hopefully you paused it and you came back. We have to figure out what angle O is. 65 and 58. I'm going to add them up together. I get 123. I take 180 minus the 123. And I get 57. So this angle here is 57. They want to know which side first is the longest. Well, I come over here and I go, 65 is my biggest. So N, I go to the two letters that aren't, it's touching, N-O, or N-O and P. So I have O-P. That would be my longest. Then it asks for the shortest. Well, 57 is smaller than 58. And that's O, so it's across from the NP. So we get side NP as the shortest. So here's your triangle inequality theorem. All right, this is what we kind of did at the very beginning. In order to know if something is a triangle, you can take any two sides. If you add them, they have to be bigger than the third side. Okay, that's kind of what we did in the opener. So if you take a look at these and you go, which one would make a triangle? So you would take 18 plus 19, 18 plus 40, and 19 plus 40. This here equals 37. Well, does 37, is it bigger than 40? 18 plus 19 has to be bigger than 40. Is it? No. Now, of course, the rest of these, is this bigger than 19? Is this bigger than 18? Those are right. Those are good. So here's kind of a little trick. Take the two smallest, add them together. They have to be bigger than the third side there. So let's take a look at this one. I've got 33, 37, and 66. I'm going to add these together. I get 70. Is 70 bigger than 66? It is. Therefore, these three pieces would make a triangle. Okay? Now, What happens when they give you two sides? You have to figure out what the possible lengths would be. Okay? The possible lengths. Well, as we said earlier, it has the two sides. So what number in 11 would be bigger than 16, right? And what number plus 16 would be bigger than 11? Well, that's pretty, but it can't be bigger than these two added together. So here's the trick. You take the two sides and you subtract them. 16 minus 11 is 5. Then you take them and you add them and you get 27. So what does that third piece have to be? Has to be bigger than 5, but smaller than 27. And so the way you write that is 5, okay, is less than x, which is less than 27. This is an inequality statement. Or you can say x has to be bigger than 5, but smaller than 27. You can always write it out in words as well. So go ahead and do your try-its. Read the questions, pause the video. So hopefully you paused it. The first thing it wants to know is, could this make a triangle? You take your two smallest ones, 16 and 28, and you add them. It equals 44. Is 44 bigger than 39? It sure as heck is. Therefore, this would make a triangle. Okay? Now for part B. What are the possible lengths? Well, as I said earlier, you subtract them and you add them. So it has to be bigger than 20, but smaller than 80. Okay, the third side needs to have a length between 20 and 80 inches. And there is your statement there. If you need to pause it and write this down, you can. This is what we learned today. All right, so what are the essential questions? So go ahead and answer all your essential questions and the do you understands and the do you know hows, and then I'll put the answers up here. But what are the issues between the sides and the angles? Here's what you can say. There's some different answers there. Number 2, if a triangle has 3 different side lengths, what does that tell you about its angles? Well, if it has 3 different sides, every angle has to be different. All right? Richard, for the error analysis, says X must be the largest angle in this triangle. What's his error? Well, we don't know what the third side is. And in my opinion, X to Z looks much bigger. So he can't say definitively if it is in fact the biggest angle, because just because 13 is bigger. Now, is X bigger than Z? Yes. But is it the biggest angle in the triangle? We have no idea. All right. An isosceles triangle has base angles that each measure 50. How could you determine whether B or the S is bigger? Well, you'd have to figure out what this angle over here is. 50 plus 50 is 100. 100 from 180 is 80. So that's 80. What side would be bigger? Would be the B. Okay? For this one here, pretty basic. If side A is smaller than side C, which is smaller than side B, list the angles in the smallest to the largest. Well, side A is the smallest. What angle would be the smallest? A. So angle A, notice the angles are capitalized, the sides are not. All right. Now for 6, 7, 8, 9, 10, 11, and 12, if you haven't done these yet, pause the video. It's okay. Pause the video and then come back to it. All right. Hopefully you paused it. So the first thing is they want to know which one is the shortest and which one is the longest and then which one's the shortest. So the first thing, again, you have to add these up. So take 180 minus 131 and you get 49. So this is 49. They want to know which one's the longest side. Well, the longest side would be across from the 83. So that would be PR. And then which one's the smallest? Well, that would be across from the 48, which would be QR. Now, these just want to determine, can you make a triangle with 2, 3, and 5? Now, some of you might say yes, but what does 2 and 3 add up to? It adds up to 5. Therefore, it would lay right on top of each other. So, no, that's not a triangle. How about 55, 76, and 112? I'm going to take 55 plus 76. I get 131. Well, 131 is way bigger than 112, so yeah, that would make a triangle. How about this next one here? We got 102, 95, and 157. Well, 102 and 95 make 197. That's definitely bigger, okay? And then the last one on 11 here, determine whether these like 17, 17, and 34. Well, 17 plus 17, equals 34, so it's not bigger than 35. So no, that's not a triangle. All right, now this last problem here. Kelsey is wielding 3 metal rods. She got one that's 15 and one that's 22. What are her options? Okay, what are her options for the third rod? All right. Well, you take the two numbers of 22 minus 15, and that equals 7. 22 plus 15 equals 37. Therefore, the third side of that triangle has to be between 7 and 37 inches. All right. That is lesson 5.4. I hope that helps.